Hello and welcome to MathematicsKicker, the Euclidean Geometry Lesson Part 3. Please like and comment and share with your friends and classmates. You can also join our WhatsApp group. The link is provided in the comment section. Today we'll be introducing the theorems, right? We grouped our theorems by the center theorems and other theorems without the center. Right. With the center theorems, we have this theorem and this theorem and this theorem and this theorem. I'm going to talk about this theorem. With the center theorems, we are going to prove two theorems on the center theorem, which is this theorem and this theorem. Right. Let's talk about this theorem. Let's analyze it. In this theorem, please write it down. Take your pen and write it down. So this is the statement of this theorem. This theorem says that a line drawn from the center, let O is the center of this circle. A line drawn from a center of a circle perpendicular to a chord, it bisects a chord. If this line is perpendicular to this one, a line drawn from a center of a circle perpendicular to a chord bisects a chord, it means it cuts BC is a chord. We talked about it that BC is a chord on the previous lesson. It cuts BC into two equal parts. It means BD is equal to CD, right? In this case, it means in this case, to conclude this theorem, we'll say BD is equal to CD. The reason is the line drawn from a center of a circle perpendicular to a chord, it bisects a chord. That is the reason for this theorem, right? We have what we call the converse. The converse, it means that if we are given a theorem like this, we can conclude by saying OD is perpendicular to BC. If we are given a theorem, then we'll be given a converse to prove a theorem. I said the statement here for this theorem, you'll say a line drawn from a center of a circle perpendicular to a chord bisects a chord. You can write it down. Then to conclude is the BD is equal to CD. The reason is line drawn from a center of a circle. That is the theorem. The reason the line drawn from center of a circle. Right. Then let's move to the second theorem. Then this one. Now we are on this theorem. This theorem says that an angle subtended by an arc, this arc subtended by an arc at the center of the circle, is twice the angle subtended by the same arc at any point in the alternate segment, right? It means in this theorem, this arc, this arc, subtend angle at the center, the same arc subtend angle at any point in the circumference. For example, this arc can also subtend an angle here. It means that this angle at the center, it will be twice this one. If we have 2x here, it means here we have x. This arc subtend angle at the center is twice the angle subtended by the same arc at any point in the alternate segment. This arc can also subtend an angle here. The same arc can also subtend angle here is twice. This angle will be x. The same arc could also subtend an angle here. I don't have a colored marker. Can also subtend angle here. We'll have what? It will be twice this one. Right. It can subtend an angle at any point in the alternate segment. Write this statement down. An angle subtended by an arc at the center of a circle is twice the angle subtended by the same arc at any point in the alternate segment. Right. An angle subtended by an arc at the center of the circle is equal to the angle subtended by the same arc at any point in the alternate segment. It means this arc subtend angle here, it will be twice the angle subtended by this arc at this point. Right. In this case, we'll conclude by saying that B angle OC is 2 times B angle AC. Then the reason is angle at the center twice angle at the circumference, right? Angle at the center. You can just write angle at the center. You understand that angle at the center is twice the angle at the circumference. This is angle at the center. That's the reason to prove this theorem. We'll be proving this theorem and this one. We'll be proving this theorem later. Then now let's move to this one. It's also a circle, a theorem with center O. If O is the center, then it means we have a line drawn from a center to the circumference is a radius, a line drawn from center to circumference is a radius, and we have two radius combined. It means, and they're straight, it means it's a diameter. The diameter subtend angle of 90 degrees. The diameter will subtend angle of 90 degrees at A. It means angle A is equal to 90 degrees. The reason is angle in the same circle. Angle in the same. If you have a diameter and we have a triangle there, it will subtend an angle of 90 degrees. This diameter subtended angle of 90 degrees at A. If we can have another triangle here, it means the diameter will subtend angle of 90 degrees here. Then the reason is angle in a semicircle or what? Or diameter. Diameter subtend angle of 90 degrees. Diameter subtend angle of 90 degrees. You can write it down. Now we are on this theorem. It's also a center theorem, right? If we have a tangent, I said the tangent, it touches the circle at once, right? And O is our center. If O is our center and we have a tangent, and a line drawn from a center of a circle to the circumference, right, is what is a radius, right? In this case, the radius is perpendicular to a tangent. We call it the tan radi. It means the tangent is perpendicular to a radius. If you have a radius, if we have a center here with a radius and we have a tangent, they are perpendicular to each other. It's also a center theorem. Then we analyze the center theorem. Please like, comment, and subscribe to our YouTube channel and share with your friends and classmates. You can also join our WhatsApp group session for more. I say peace.